Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at productivity models. They're not as complicated as they sound. It's just a logarithmic equation that models how much of something you can do over time. So let's look at this example. Ethan starts at the gym and he bench presses 50 kilograms. 6 weeks later, he can bench press 70 kilograms. How quickly is he increasing his bench press after 6 weeks? So there's a lot in this question, so let's look at what's going on. So firstly, we want to model Ethan's progress with an equation. So why would we choose a logarithmic equation? So remember, logarithmic equations look like this, and they're great for things like productivity, for situations like this, because what tends to happen is you increase your performance a lot at the start, but then those gains that you get slow down. We wouldn't want to use a linear model for this because no one, when they go to the gym, makes exact same progress week after week. Otherwise, you'd be having people who can bench press like 500 kilos after a year. So a logarithmic function is great for productivity because, as I said, you usually experience gains really quickly at the start and then the gains slow down. So we're going to aim to come up with an equation of this form that models this information. So why do we use ln natural log? The reason is it's easy to differentiate, and we're going to end up differentiating in this question. The reason we use t plus 1 in the brackets rather than t is we want to start at time t equals 0. So you can't just have ln of t because you couldn't substitute t for 0. Remember, ln 0 doesn't exist, so you can't just have ln t and then substitute for 0. That's why all productivity equations we use t plus 1. So what we're going to do is start out with an equation of this form and find the values of a and b, which are just constants. So in this equation, y is going to be the number of kilograms that Ethan can bench press. So t is going to be in weeks because the question was about weeks. It actually wouldn't matter if we put t in days. We'd just get a different value for b then. Okay, so let's substitute in the information. So at the start, when t equals 0, we have y is equal to 50. So we have 50 equals a plus b ln of 0 plus 1. Again, the reason it's t plus 1 is so we can substitute t for 0. So the natural log of 1 is just 0. So we found here that 50 is equal to a. No coincidence there. A is always the initial value, how many of something you can do at the start. So how are we going to find b? Well, we're going to substitute y for 70 kilograms and t for 6 weeks to find what b is. So we have y is equal to a plus b natural log of t, so t is 6 weeks, plus 1. So all we need to do in order to solve this is subtract 50 from both sides and then divide by natural log of 7. So putting that on our calculator, we get b is about 10.277967. It's not a nice number. So this is the equation for Ethan's productivity. Y equals 50 kilos plus b 10.277967 ln of t plus 1. So that is the productivity equation of what it can lift after t weeks. So now we want to know how quickly is he increasing. So whenever you're asked how quickly or you're asked for the rate of something, you should think of derivative. We need to differentiate this function and substitute t is equal to 6. So to differentiate this function here isn't difficult at all. Remember, of course, when you differentiate, the constants vanish, so we don't need to worry about that. Now, to differentiate this, it's just going to be that constant out the front, b, 10.277967, all divided by t plus 1. So again, that's why we use natural log here. We could have used log of any base. The base would give us a different value of b, but the reason we choose log base e is it's very easy to differentiate. So if I substitute into this expression here, t is equal to 6, I get this. And that gives me about 1.47. So what we're saying is after 6 weeks, he's increasing his bench press by about 1.47 kilograms per week. Because as we know with the productivity model, the productivity slows down. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.